Hi guys, we're here at Geometry C working on right triangle trig applications. You should have got a note packet from the substitute teacher, and I'd like you to please turn to page 10. So we're all looking at the same guided notes. I know this is the first time we've used guided notes in this chapter, but the reason being is because everything up until now we haven't had any word problems, and now we are. So I'd rather give you guys the word problems to work off of instead of having you write the word problem down every time. So today we're going to be talking about right triangle trig application. So we're going to be using our skills of SOHCAHTOA, sine, cosine, and tangent, but now on word problems. The way this lesson is going to work is we're going to walk through the notes, do about 5 examples together, and then you're going to finish the rest and check your answers with the substitute teacher. Okay, so if you're looking at these notes on page 10, I'd like you to take a look at the top. We got 2 definitions here, the angle of elevation and the angle of depression. Okay, the angle of elevation is the angle above horizontal that an observer must look to see an object. Okay, so down here you see our observer, and he's looking up at an angle of elevation. And what you'll notice is it's always off the horizontal axis here. Okay, and this is going to be true for angle of depression as well. So angle of elevation, start with the horizontal, and you're going up to find that angle of elevation. Okay, for angle of depression is the angle below the horizontal. Okay, so both are off the horizontal, that an observer must look to see an object. Okay, so in this definition, we have our observer right here, and here's the horizontal off the observer, and the angle of depression is below that horizontal. So angle of elevation is above the horizontal, and the angle of depression is below the horizontal. Okay, so I just want to keep that in mind. It's always off the horizontal because the angle of depression gets kind of tough. Okay, so now for these word problems, what you see, as you move down, we're going to have the same set of skills the entire time, the same procedure. So for each word problem, you must draw a diagram, determine what distance you are asked for, and label it x. Write an equation using our appropriate trigonometric ratios, remember SOHCAHTOA, sine, cosine, tangent, and then use your calculator to solve the equation. We're going to round all of our answers to the nearest tenth. That's 1 decimal place. Okay? So let's try one example together. So, a ladder is leaning against the side of a building. The ladder forms an angle of 48 degrees. Okay, so it's going to be an angle of elevation. You'll see that. If the ladder touches the building at a point that is 15 feet above the ground, how far is the base of the ladder from the base of the building? Okay, so we actually already did this problem for you. So if you look at the left side of your screen, here's the diagram. Okay, we have our ladder up against a building. Okay, and it says that the ladder is 15 feet off the ground. So that's why I labeled this distance right here 15 feet. Angle of elevation is always off the horizontal. Okay, so that's why you see here's my horizontal. And angle of elevation is above the horizontal at 48 degrees. And now what we need to do is we need to find the distance between the bottom of the ladder to the bottom of the building. That's why we labeled this ground x. And now what I want you to do is label the sides. If we're given 48, this angle right here, we need to label which are opposite, which is the hypotenuse, and which is the adjacent. So we can figure out which trigonometric ratio to use. Well, if we're starting at this angle 48 degrees, you'll see that we're given the opposite side, and we are searching for the adjacent. That's why we're going to be using our tangent. So the equation you see is tangent of 48 equals 15 over x, right? Because tangent is opposite over adjacent. And now we need to multiply both sides by x, and then divide by tangent of 48. And if you plug that in your calculator, you will get the solution of 13.5 feet. Okay? Let's try 5 more together. So flip the page over, and now we're going to have to draw these ourselves. So it says a ladder is leaning against the side of a building, forms an angle of 50 degrees with the ground. If the base of the ladder is 12 feet from the base of the building, how far up the side of the building does the ladder reach? Same idea. So I'm going to draw my building. Okay. And we're searching for the height of the building, so I'm going to label that x. Now I'm going to draw my ladder, just like the last problem. And now we're given an angle of 50 degrees. Okay, with the ground. But it also says that the ladder is 12 feet up the base of the building, so we're given that this is 12 feet. Okay, so I'm going to label my sides. We're talking about this angle right here. That means we're given the opposite and the adjacent. And now which trig ratio uses that? Tangent. So we're going to say tan of 50, that's the angle, tangent of a 50-degree angle is equal to x over 12. And now we need to solve for x. Multiply both sides by 12. And plug in your calculator. And remember, we're rounding to the 10th, so we're going to go 14.3 feet equals x. So I'm saying that the base of the ladder is 14.3 feet from the base of the building. Okay, look down at number 2. They're going to get a little bit harder with the diagrams, but the procedure is the same every single time. Okay, so a kite is flying at the end of a taut string that is 175 feet long. The string is attached to the ground. The angle of elevation of the kite is 68 degrees. Okay, so here's my ground point, my ground stake. I'm going to draw the kite. Okay, there's my kite flying. Remember, angle of elevation is always off the horizontal, so elevation is going to give me this 68 degrees. Okay, it also says the string is 175 feet long. Okay, but we need to find the distance from the kite to the ground. So we're searching for this distance right here. So I'm going to label that x. Okay, and if we're given this angle, which sides do we have to look for and which one are given? Well, we're looking for the opposite side, and we're given the hypotenuse. So which trig ratio uses that? Opposite over hypotenuse, that's going to be our sine ratio. So sine of 68 equals opposite over hypotenuse. Multiply both sides by 175. Okay, plug that in your calculator and you should get 162.3 feet. Okay, so I'm saying that the kite is 162.3 feet from the ground. We're going to do 3 more together and then you have to finish the rest yourself. Okay, Ellen standing on a 1,000-foot cliff. So let me draw that 1,000-foot cliff. Here's Ellen standing on the cliff, 1,000 feet above the ground. Okay, and then she spots a deer on a 700-foot cliff. Well, I can't really draw a deer, so I found one. There's the deer. Okay, so the deer is on a 700-foot cliff on the other side of the valley. If Ellen is looking down at the deer at a 30-degree angle, so this is tough because this is our first angle of depression. Okay, remember it's always off the horizontal. She's looking down at this deer. Remember, angle of depression is always off the horizontal, so this means this is going to be a 30-degree angle right here. Okay? And now what we need to do is we need to create a right triangle. So what I'm going to do is I'm going to drop this altitude right here, create a 90-degree angle. And now, if Ellen's on the 1,000-foot cliff and the deer's on the 700, what is the difference between the two? Well, I can calculate that by taking 1,000 minus 700, and I know the difference between the two is 300 feet. Okay, so if this is the angle we're given, 30-degree angle of depression, we need to find how wide the valley is. So I'm going to label this as x between the two 1,000-foot cliff and the 700-foot cliff. So now I have an angle of depression of 30 degrees. I'm given the opposite, and I'm given the adjacent. Kind of hard to see, but this is my hypotenuse down here. Opposite over adjacent, we need to use tangent. So tangent of 30 equals opposite, which is 300, divided by x, which is adjacent. Multiply both sides by x, so I get x times tangent of 30 equals 300, and then divide by tangent of 30. Okay, plug that in your calculator, and you should get 519.6 feet. So the valley is 519.6 feet wide. Okay, we got 2 more. A chairlift at Natural Bridge travels 400 feet from the base of the hill to the top of the hill. Okay, let's see if I can draw a hill. There's our hill. Okay, the chairlift travels 400 feet from the base of the hill to the top of the hill. If the angle of depression from the top of the hill is 30 degrees, remember angle of depression is always off the horizontal. So here's my horizontal. Let me create my right angle here. It's 30 degrees. Okay, so we're given this angle. Find the height of the hill. Well, the height of the hill is going to be way over here, so I'm going to call that x. And right now, this is what we have. We know the chairlift is 400 feet long. So I know this distance, 400 feet. Okay, well here's our angle. I'm going to circle the angle and figure out which sides I have. Well, across from the 30, that's going to be my opposite. And then across from the 90-degree angle is my hypotenuse. So I actually have opposite over hypotenuse. We're going to be using sine. So sine of 30 equals opposite x over 400 hypotenuse. and I need to solve for x. So I'm going to multiply both sides by 400. Plug in my calculator, and you should get 200 feet. Now one thing I want you to notice is because we're using a 30-degree angle, we could use our 30, 60, 90 special right triangle. We could have set 400 equal to 2a, because that's what's across from a 90-degree angle. Solve for a, and we know across from the 30 is our a, which would have given us 200. We got one more problem together. This one's kind of tough to draw, because I cannot draw a boat. We're going to try. So the distance from a boat to a bridge. Okay, here we go. Here's my boat-ish. Okay, we got our boat. It's 200 meters from a bridge. Let me draw a bridge. Kind of looks like the ladder we drew a few times, whatever. So we have our boat to the bridge is 200 meters. So let me draw that distance right here. 200 meters. A person aboard measures the angle of elevation to the bridge. Now remember that angle of elevation and depression are both off the horizontal. So it's going to be above the horizontal, so we know that this is 12 degrees. How far above the water is the bridge? So I need this distance right here. Label it x. Okay, so we're given this angle down here at 12 degrees. We're searching for the opposite, and we are given the hypotenuse, because here's my right angle. And now which trig ratio uses opposite over hypotenuse? Well, that's sine. So sine of 12-degree angle equals x over 200. And I need to multiply both sides by 200. Okay, plug that in your calculator, and you should get 41.6 meters. So we're saying that this bridge is 41.6, approximately 41.6 meters above the ground. Okay, so we've done 6 problems together. If you flip the page over, you'll see problems 6 through 12. I would like you to please try these. If you are done right now and you see a partner who you can work with, please work with that partner. Try 6 through 12. You're going to need to draw the diagram for yourself for all 6 problems. And then you can check the solutions with the sub, and they will also be online. Okay, guys, enjoy.